right, you guys. Hi, welcome to Chapter 6. Today we're going to go back to the normal distribution. In Chapter 3, we worked a lot with the normal curve, and we worked with the empirical rule. That was the 68, 95, 99.7%, where we went 1 or 2 or 3 standard deviations above the mean. Okay, so if we recap a little bit of information about your normal curve, all right, we know that it's continuous. It'll keep going this way and keep going this way. It's symmetric. Okay, mirror images, bell-shaped distribution of a variable. We also know that your normal distribution is going to have a mean of 0, which means mu equals 0 is right here in the middle, and a standard deviation of 1. Right? And what we want to talk about, right, is we want to talk about z-scores, which we also worked on in Chapter 3. Okay, so all of this up here is a review from Chapter 3. So when we dealt with z-scores, that was when we did this formula, z equals x minus mu over sigma. The easiest refresher I could give you is when we talked about comparing SAT scores to ACT scores, how they're on two different scales, but by computing the z-score of each of them, it brings it down to the same scale. So what we need to remember, okay, is that your z-value or your z-score is your number of standard deviations that a particular x value is away from the mean. So a positive z-score would go this way, which means that your x value is above the mean. A negative z-value is below the mean. So negative z-scores come over here, and positive z-scores are over here. If you have a z-score that is equal to 0, then that means that your x value is equal to the mean. All right. So when you're looking at these, when we worked in Chapter 3, we always dealt with a perfect 1 or a perfect 2 or a perfect 3 standard deviations above the mean. We only did 1, 2, and 3. Now we're going to get into any kind of decimal we can think of. All right, so when we're working on our z-scores, and I put a note here, all right, that in your textbook, pages 316 and 317, give excellent instructions with diagrams of what we're about to do as well, okay? This here is one of the most important concepts to lay a good foundation for the rest of the school year. We're going to go slow. We're going to do a ton of practice because we need to make sure that we're amazing with this before we move forward, okay? So what we've got is when you're working on the normal curve, your area is in here, okay? And one of the biggies to remember is that the area always adds up to 1, okay? If it's symmetrical, then that means that half of the area is to the left of the mean and half of the area is to the right of the mean. Area is always going to be positive. It's your percent inside, or your proportion of values that are inside your curve. Okay, so if we've got a problem like this, example 1, we want to find the area under the standard normal distribution curve that's to the left of z equals negative 2.34. So your first question is, from the mean of 0, you'll notice I just pre-drew all of my curves with the mean of 0. If your mean is 0, then negative 2.34 is a negative z-score, which back up here we said is below the mean. So we're going to draw it lower than the mean, and we're going to have negative 2.34 is our z-score. Z-scores come down here along the bottom axis. But we want to figure out what region to shade, okay? We want to the left of that. So the left of this is this space here, okay? And what we're looking for is we're looking to find the area here in this shaded region. And in order to do that, we're going to be using this green table that I gave you. Okay, it's a stapled packet. If you don't have it picked up, I got this out of your textbook. So you can open your textbook to page 788. All right, but a lot of you guys hopefully picked them up from the office. So you grabbed them from me in the classroom. All right, one important note about this paper is you don't want to write on it. We're going to be using tons and tons and tons of these numbers. So if you begin circling things, it's going to get really clogged up really, really quickly. Okay, so what we've got is we're going to work on the first page, the front and the back. You'll notice Up here it says the standard normal distribution. You'll see, hopefully, that right here, whoops, right there, you have a z, which means your z-scores are on the outside here. Okay, the first two digits are on the left, and then the hundredths place is out here on the right, and I'm going to show you how we use these. This entire first page are your negative z-scores. So if you ever have a negative z-score that you need to look up, you're going to use this first page. You'll notice down here at the bottom, they give you this picture, which means that the area, all these numbers inside your table are the areas. Okay, so if you want, maybe you want to like make a little note that for your chart, okay, the area is inside and your z-scores are outside. Okay, so like your chart, here's the area are the numbers inside and your z-scores are the numbers on the outside. On the second page, if you open up your packet, okay, you'll see it says continued, and we still have more of the standard normal distribution, okay? But this time, when you look at it, your z-scores are positive. They're all the positive z-scores on this side, okay? You'll notice the area is bigger. The z-score is now on the right. It's above the mean. So it's a positive z-score, okay, over here. And these areas in this table represent the area here in this shaded region. Okay, so for this first problem, if we want to find the area to the left of z equals negative 2.34, this is a negative z-score. So I'm going to come in my chart, and it might be helpful for you guys to use like an index card or another sheet of paper. Okay, I use it as a horizontal like lineup to help me get my, make sure I don't jump. Okay, so I'm going to go to the negative 2.3, and then I need to connect that with the 0.04 because the z-score we're looking up is negative 2.34. So this 0.0096 is my answer. So again, I got that from negative 2.3 and 0.04 for my z equals negative 2.34. So the area for that was 0.0096. That's my answer. All right, a very tiny fraction of the problem. Now, if you look, see how this shading matched this shading? Okay, when they match like that, then that means that the area you look up in the chart is your answer. Okay, it's the same area. So if we take a look at the next one, okay, number 2, we want to find the area under the curve that's to the left of z equals 1.99. So 1.99 belongs where? If here's 0, 1.99 belongs to the right. Now you might be saying, well, how far right do I have to go? It doesn't really matter. For our purposes, we really kind of get this is like positive 3 and this is negative 3. At the ends, technically, they go to infinity and negative infinity. But for our purposes, at the Stats 101 level, we go to 3 and negative 3. Okay? So we have 1.99, and we want to shade to the left of z equals 1.99. So I'm going to shade all of this. Now, be careful. Which page do we want to use in our green chart? If we have a positive z-score, then we don't want to use the front page because the front page are all the negative z-scores. That's when we want to use the second page for the positive z-score of 1.99. So I find 1.9, and then I'm going to use 0.09. All right, so I'm going to use 0.09, and hopefully you'll see how the purple line is helpful, right? My purple index card. So if I have 1.9 and 0.09, then I get this, 0.9767 as my answer. Okay, now take a look. See how the shading here matches our shading here? That means that from negative infinity up to this line of 1.99, we get an answer of 0.9767. That's my shaded region. All right. Well, let's take a look at number 3. Okay. So number 3, we want to the right of z equals 1.99. So we have the same z-score this time, but our shading is to the right of that. So if our shading is to the right of that, we still have positive 1.99 as our z-score. So if we look it up in the table, we're going to get the same exact answer we did last time, 0.9767. But we have to remember that the 0.9767 in the table is from here, is from here to here. It's this space. We want, for this particular problem, number 3, to find this space. So when you have 0.9767, that's this space. How are we going to find here? Well, let's go back to that beginning concept. We talked about how the area under the curve always adds up to 1. So to find our shaded area, all right, we could say shaded area is 1 minus 0.9767, which would leave us with 0.0233. Okay, your answer needs to be logical, guys. This one was more than half, so our answer of way more than half makes sense. If you circled 0.9767 and this is your shaded region, this is not more than half. It can't be 97% of, almost 98% of the normal curve. Okay, so step 1, draw your basic curve. Step 2, draw the line of where your z-score is. Our z-score for this one is negative 0.58. So it's to the left of 0, negative 0.58. Now I have to figure out where we're going to shade. We want to shade to the right of negative 0.58. So I'm going to shade here. Okay. Negative z-score means we're looking on the front. Okay, so we're on the front where our negatives are. We're going to find negative 0.5 right here. We're going to find 0.08 here. And I get an answer of 0.2810. But remember, 0.2810 is this here, this tail from negative infinity up to the line. That's why this picture is here as a reference. So 0.2810 is this space, which means 0.2810 is this space. So how are we going to find our shaded region? Our shaded region is the rest. So our shaded area is 1 minus 0.2810, which should give us 0.7190 right there. Logic, checks and balances, we shaded more than half, and our answer should be more than half. All right, so let's take a look at another guy. All right, we're just going to go through a bunch of different scenarios. It's all the same concept of just pictures looking slightly different from each other. Okay, so if we've got this one, we want between z equals 0 and z equals negative 1.75. Z equals 0 is this line. Z equals negative 1.75 is going to be here to the left. I want between them, so I want this space. So if you look up negative 1.75 in your chart, then hopefully you are getting 0.0401. But 0.0401 is here. Because remember, the negative z-score is this area in the tail. We want this space. So how am I going to find this space? Well, let's think about it. What do I know about this? This is how much of the curve? 0 to the left. This is half. So would you agree that from here to here is 0.5 or half of it? Right? So then if that's half of it, then we can do our shaded area. We can subtract those two areas. we can do 0.5 minus 0.0401. And that will leave me, right, because see how I could like take away what's overlapping and it'll leave me with just this. And that will leave me with an area of 0.4599. Okay. So let's go to the next one. All right, and if you want, you can like pause. If you're like, oh, I think I'm getting the hang of this, I want to try some on my own, like pause, try them on your own, and then come back to me. All right, so we're going to have between z equals positive 1.68 and z equals negative 1.37. So I've got those guys. All right, so I went between them, so I want this area. Sometimes it's helpful if I grab color. Some people do better with like set it up in one color and then use like a colored pencil or something. Okay, we have 2 z-scores. You probably really need to put a note right here. You're never allowed to subtract z-scores. You always have to look up both z-scores, find their areas, and then deal with the areas afterwards. So you're going to look up z equals negative 1.37 on the front chart because that's your negative z-scores. And when you look up negative 1.37, you get an area of 0.0853. Okay, then you're going to look up positive 1.68, the z-score of positive 1.68 on the second page. And when you do that, you get an area of 0.9535. But remember, positive z-scores always start here and go up to there. So the 1.68, this area was 0.9535. So to find my shaded area, I'm going to do the same concept I did back here. But instead of doing 0.5 minus, the reason why I did 0.5 this time because it was a perfect half because it was at 0. This time it's not at a perfect half. So I'm going to say shaded area. You do the big area, 0.9535, minus the small area, 0.0853. And that leaves us with 0.8682. All right. So I'm hoping you guys are getting comfortable with this and you're saying, all right, I'm catching the swing of this. This is making sense. Okay, and if it's making sense to you, then that's awesome. All right, and then pause, cruise through. So we're just going to do 7, 8, 9, and 10. Okay, and then actually you guys do them. All right. Pause it. I changed my mind, pause it. And I'm going to give you the answers in a sec. And then if you don't get the same answers, I want you to ask me in class so we can go over them together. All right. For number 7, your answer should be 0.016. For number 8, your answer should be 0.1967. For number 9, your answer should be 0.0075. And for number 10, your answer should be 0.0013. Okay, so you guys try them and then come back, like touch base with me and we'll go over them together. Okay, if you don't get them, you have to let me know in class so we can go over them. Nice job today. This is extremely important that you take really good notes. So good job today.